Welcome to our presentation on drone LiDAR, deliverables, and cost. Let's start with giving you an overview of what we're going to be discussing today. We're going to start with Texas Drone Professionals, who we are, move on to what is our experience in this industry. Then we're going to cover strengths and weaknesses of drone LiDAR. Then we're going to talk about the accuracy of drone LiDAR. Then we're going to go over the workflow. How do we get from what a customer might need to actual deliverables from us to that customer? Then we're going to go over some job examples and then cover some use cases of how we might use drone LiDAR. Then we'll get into possible deliverables, different deliverables that our customers have needed in the past, and possibly what deliverables you might be able to use within your company. Then we're going to cover the cost of using drone LiDAR, then go over the feasible size, what area can we cover, say in a day or in a few days, give you an idea of what is feasible with drone LiDAR. And then we'll get to some question and answers, some basically frequent questions we've been asked at different presentations. To start with, who is Texas Drone Professionals? At the very beginning, let's emphasize we are not surveyors. We collect data for surveyors and different engineering firms, but we ourselves are not surveyors. We are experts in UAVs and experts in drone LiDAR, but we are not surveyors. Our history. We've been involved with UAVs for over 35 years, both designing and flying them worldwide. We are also FAA approved to fly. We have our 333 exemptions, and all our pilots have their Part 107 licenses. So we are both federally approved and follow all state and local guidelines for flying commercially with UAVs. We also carry $2 million in liability insurance, and we can increase this as needed depending on the customer's needs. Experience. We've been flying drone LiDAR for over 2 years now. We started by cooperating with one of our local engineering firms, McCord Engineering, to provide deliverables for the electric utility industry. With McCord, we've worked extensively on developing deliverables to fit within the electric utility industry. Basically, how do we get the data we have in a format that's good for engineering firms and electric utilities to use in their industry? We've also worked closely with local surveyors on providing the data they could use, such as topographical mapping or the direct LiDAR cloud, which they can put into their engineering programs to develop the deliverables they might need for their customers. Strengths. What are the strengths of drone LiDAR? One of the big strengths of drone LiDAR is excellent tree canopy penetration. With this LiDAR, we're getting over 700,000 shots per second. So we get very, very dense data. In the example to the right, we see we have over 538 points per meter square coverage with this LiDAR. Full-size aerial LiDAR is often in the range of 50 to 80 points per meter squared. So drone LiDAR in the range of 500 points per meter squared is much denser, giving you much better tree penetration. So we can go along shooting with this LiDAR and get very good tree penetration just because of the pure density of the LiDAR shots we're taking. Another advantage of drone LiDAR is in heavily treed areas or where there's other obstacles where you might have issues with RTK signal, such as if you're walking out there with an RTK unit. We're actually flying over all those objects that might block your RTK. So we're having very good accuracy even in very dense areas because we're simply flying above those areas. Another advantage of drone LiDAR is we're feasible for small areas because our cost to simply get us out there compared to, say, a full-size aerial LiDAR, the cost is low, so you can get out there and do maybe an acre, 10 acres, 20 acres, or maybe a mile of line or something, but it's very feasible because of the basic costs. The other strength of drone LiDAR is up-to-date data. So instead of having to use 6-month-old data or 2-year-old data from LiDAR, we can get out there and get you data in a few days, and you have very up-to-date data for whatever your engineering or survey project might be. Weaknesses of drone LiDAR. What are the weaknesses? We cannot penetrate water. Like any LiDAR or most LiDAR systems, you're going to get a void where there may be water. Another disadvantage is another weakness, is you could not see buried items. So in comparison to someone walking out there surveying the property who might be able to find buried items, LiDAR will not find those. Also, in flat open areas, such as maybe a parking lot, there's not a real cost advantage to LiDAR because it's such a simple area. It may be easier just to shoot one end of the parking lot and the other end of the parking lot. Now, kind of a flip side to that, we have had a customer that had what looked like a fairly big flat open field where they were having drainage issues. We went out and shot that property, and because the LiDAR penetrates the grass so well, we found a lot of terracing in that property that they really didn't even know was there, even though they drove that property all the time. And we were able to give them a map of that terracing, and they were able to plan culverts based on the terracing and fix their drainage issues. So sort of a flip side of that, there's even some cases where you think it may be flat, but the LiDAR can point to you that's actually not. Another weakness of drone LiDAR is we do have to remain visual line of sight. So we have to plan out our flights so that we can stay in visual line of sight of the aircraft while we're collecting data. And in some applications, some situations, that may not be possible depending on the exact terrain. In most cases, we can work around that, but it is a factor. And at the moment, that is true simply because of the FAA. That is simply a legal requirement that we must maintain. In the future, that may go away as they're getting beyond line of sight rules, but at the moment, that's still a weakness of drone LiDAR. Accuracy. What is the accuracy of drone LiDAR, and how do we confirm the accuracy of the data that we take? First of all, the basic relative accuracy of the LiDAR unit itself is at worst 2 centimeters XY and 5 centimeters Z. The LiDAR itself is actually better than that, but that's just a good general number to give you, keep in your head of what the basic accuracy is. So that's relative accuracy of the LiDAR itself. We then go in and do ground truthing, so we need the surveyor's ground control to match our Cloud 2 to make sure we've moved everything down so our absolute accuracy is matching what someone would get on the ground if they took an RTK unit out there. We then want to make sure to do in-field validation of the data. You can either do every job, or you can do it, you can scatter it among jobs just to confirm the data we're getting is consistently accurate with what a surveyor would expect of this data. We will also talk a little more later about how we can use the data we collect to help surveyors check the accuracy. There's a few specific things that we recommend so that they can quickly validate that our data is getting to them, the data that we are getting to them is accurate. Workflow. How do we get from what you need to actually getting your deliverable? We start by defining the job area. We often do this using, say, a KMZ off of Google that just basically lines out the area in which you need flown or need data from. We then need to define what your deliverables are. Do you need a topo, a point cloud, possibly cross sections going through a creek or something to tell you elevations? So once we define the deliverables, we then move on to confirming the property access permissions, making sure that we have access to the areas that we need to collect the data. We then check for any COA requirements. COA requirements are simply certificates of authorization from the FAA that we might require if we're close to an airport or critical infrastructure. We need to make sure we have all the approvals to fly in those areas, and we as a company take care of that for you. Then we plan the mission. Then the ground control can be set either by us or surveyor or another party involved in the situation. We then go out, fly the property, process the data, and then create the deliverables. Now, one of the most important steps in this is getting feedback from the customers on the deliverables. Once we get the deliverables to the customer, we would like feedback to make sure that they can make use of the data in the format that we sent them, whether it's a topo or the actual LAS cloud. Because we often had customers who requested the raw LAS cloud and their software can't run it properly. It's too dense. It's a very easy step for us to simply reduce the density. Same thing with topos. We've in some cases gotten topos to customers and either it was too detailed or not detailed enough. Again, very easy to refine those deliverables. We have all the data very well defined in our 3D clouds and in our DTMs. We just need to make sure the format that we give it to the customer, they can make the best use of that. And that usually takes some steps, especially with a brand new customer, to make sure they're getting the best format of the data to make it the best use for in their software. Okay, here's an example job we did for a customer. This, you can see from the side view, this is quite dense trees. As we move along in this video, you can see how just foot access to this property is very, very difficult. To actually walk in there with an RTK unit would be quite difficult. Even just seeing in there is quite a problem. Here's the actual result of the data that we flew. You can see it's a pretty good example of a job that's great for drone LiDAR. It's got a mix of everything. It's got open flat area, it's got little lake, it's got some sort of swampy areas, buildings, trees, power lines, all kinds of things. This is great for drone LiDAR just because to the drone it's all the same. We're keeping high precision throughout the entire job. It penetrates through the trees so we can get good ground coverage even in the trees, so we get good DTM out of that. So even though it's very difficult foot access for a person, for the drone it's no problem. We can simply fly over and collect the data just like a lot of other jobs. Here's an example of the actual LiDAR cloud that we collected. On the left is this property with all the trees still included, the power lines, the buildings, all the structures, everything is still on the one on the left. On the right-hand side, we've gone in and removed all the trees, the power lines, the buildings, and created a DTM of the property. And you can see how all the detail of the ground really comes out. What you can't see on the left image, you can very well see on the right image, showing all the detail of the ground that we've gotten through the LiDAR penetrating all the vegetation to give you a real accurate image of what the ground is. Now if we look in the center area here around the creek, in this next slide we're going to be doing a close-up of that particular area. Okay, here's a close-up of the area we talked about. This is an example of one of the kind of deliverables we can give to a customer. The red lines are demonstrating a cutaway that we can do to show you different elevations around that particular feature. On the left, you're actually seeing the elevations going through that creek, and we can do these cutaways on creeks or buildings or curbs or whatever it might be. So once we have a very accurate 3D model of the real world in the computer, we can go through and pick out what kind of data is best for the customer. Here again we have the elevation grid on the left-hand side. On the right-hand side is an example of a smooth topograph that we gave to one of the customers. In blue we also have outlined the water features that were there during the time that we were flying it. This I want to use as an example of, okay, how would a surveyor confirm if our data is good? We have a smooth topo, which is obviously much less information than what we have on the left, which is a very detailed DTM of the entire area. The way we'd recommend surveyors check our data, we would give them random points from our DTM on the left, put them on the topo as dot locations with their X, Y, and Z for them to be able to go out in the real world and confirm those points match. So in the middle of the process somewhere, they're going to give us ground control that we match our cloud to. And then at the end, we'll give them different locations and different points they can go back out and ground truth to make sure that our cloud is matching what their real world measurements give them. Now, use case. This is a use case example for drone LiDAR. This is a good example of a more urban area where access to a person with an RTK unit would be difficult because there's vehicles and roads, and access to doing a lot of the area of the road would be difficult. Whereas with the drone, we fly on side areas over the grass. So we can fly on the north side and then on the south side of the road, and getting data on both sides of the road without ever being on top of any of the vehicles or not having an issue with safety having to cross the road. The other good thing about this is a use case. This area changes very frequently. They're redoing the road, they're building new apartments, they're doing all kinds of things that change this on a regular basis. So 6-month or year-old data is not really accurate anymore. Well, we can run out there very quickly and fly this job and get you accurate, up-to-date data of that area. Here's another use case example over the Colorado River. The time we flew this, there had been a lot of heavy flooding through the area. This is a good example of a heavily treed area that's very difficult to access, trying to measure what's going on in the steep areas of the creek, which the cutaway on the top right shows the steep areas of the creek. That's the raw data cloud without any of the trees clear, but you can see we get a lot of tree coverage, we get a lot of good ground through that whole area. It's a very good way of showing the detail going on around that river or creek and through the trees, even in an area that would be difficult by foot, and especially difficult by foot and right after large rains and difficult access to steep areas in that area. So it's a good example of where drone LiDAR really shines in areas that would be very difficult for a person to access. Lastly is another use case. This is a very heavily treed area. On the bottom left, you can see where we pulled a map off of Google Earth. The area just to the top right above the golf course is where this treed area is. There was very poor access by even foot, and certainly vehicles really couldn't access half the property. But we were able to fly over it using the drone get very good penetration through the trees and get all the way down to the ground. So as this GIF shows, as we remove the trees, we still have a very viable, very good DTM of the ground to show you beneath the trees. Deliverables. What kind of deliverables are we providing for our customers? Just some of the basic examples. Some want the raw LAS cloud. That's the most basic form of the data that we create. That's every single point that was shot of the cloud itself. So you can go in and measure any place, anywhere in the cloud you want to, create your own topos, create your own cutaways, whatever you might do within your software. The main thing with the LAS cloud is the customer needs to make sure that their software and computer can support the density of these clouds. That's one of the ones where we often need to reduce the density simply so their software will run it efficiently. That's one a lot of engineering firms like to get because they can do so much with it. A more processed version of the data is an elevation grid or a DTM. In this case, a ground only. Customers will often use this to create their own topos or do other measurements on the data. Another example we give to customers is topography mapping. That's the one where we're simply creating the lines of the basic elevations there. We can create those in many different formats, depends on what your customer might need. We can also do it in many different resolutions. Because we have such a high density data in our 3D cloud, we can do almost any, half a foot, 5 foot, 10 foot elevation changes on a topo map. It's really whatever the customer might want. Path profiles, that's the example we gave earlier going through the creek, where we can do a cutaway wherever you might want the cutaway and get very accurate measurements along that line for the area you may be trying to measure. Ortho-rectified mosaic, that's just an image from above so you can see all the stuff that is happening above it, that's happening on that property. The example we have here is actually one that was created off of Google Earth. Ours ends up looking about the same as that. The difference is ours is the most up-to-date image. So the customer we did in this case didn't need that up-to-date an image, so we simply overlaid a Google Earth image for them to give them general reference of where things were. So you get a good real-life image to help them position where they are when they're looking at the data, but we can also create it while we're collecting it so you have the most up-to-date images for the mosaic. Another option is high-resolution images. Different customers need to know what's going on that site while we're flying it. Like in some cases, we may be getting utility poles, or we may be getting different structures on the property so they can do closer inspection of what's going on with that, or even creeks. They want more just basic images to give them a visual cue on what's going on in that area. So those can be taken at the same time that we're taking the other data. Special deliverables, that's a case where we've already got a very detailed 3D model of your data area in the computer. You can do all kinds of other analysis on that data, things like flood analysis, line of sight analysis. If you're standing here and you look that direction, can you see the top of a hill or the top of a tower, or are you going to see a tree or a hill? There's all kinds of different things we can do with 3D data once we have it, and that fits in the realm of special deliverables. Costs. What does drone LiDAR cost? Please join us at one of our live lunch and learns, or contact us through our website, www.texasdroneprofessionals.com. Feasible scale. What scale is feasible for drone LiDAR? With the X8 LiDAR drone we are presently using, we do about 50 acres per flight. We can do in the range of about 12 flights a day, so about 600 acres in a day is a feasible scale. If you're doing more linear flying like we do for utility companies, we do about 1.25 miles per flight in the range of 12 flights a day, so again about 15 miles in a day. It's also possible if customers are wanting larger projects, there are other aircraft we can use to give them even larger projects. At the moment, most of our customers are wanting more the scale described in the two ones above, but for larger projects, we can develop other aircraft to fit those needs.